So we are gathered here for a case study discussion on capacitive sensors in touchscreen in mobile phones. So before starting with the discussion, let's have a quick recap about the sensors and as well as the capacitance. So we all know a capacitor is a device that is capable of storing the energy in electric field. So similarly, as far as the construction is concerned, we will be having two parallel plates which are nothing but it is a conducting one. It will be separated by a dielectric medium. So two parallel plates separated by a dielectric medium is a construction wise capacitance. And the sensors is one which will respond to the input. So whenever there is a change in the input, there will be a change in the output. Sensors plays a crucial role in modern technology. It has been employed in a variety of fields, starting from measuring the temperature, heat, proximity, motions, everything sensors are being employed. And we are going to discuss about this capacitive sensors. So capacitive sensors works on a principle of this capacitance, and it is being used in the touch screen. It is used in gadgets, in touch screen as well as in laptops, and especially in mobile phones and tablets. Everything being this capacitive sensors are being used. And here we are going to have a case study discussion on this capacitive sensors, especially in the touch screens, in gadgets. Okay. So we are 5 members are employed over here. So we are going to discuss about this introduction part and problem statement, and we are going to discuss about this advantages, drawbacks and applications of this particular capacitive sensors in touch screen. Okay, let's start the discussion. I call upon Dharani.
Thank you, ma'am. Hello everyone, I am Tharani from second year ECEC. I like to give a small introduction on this topic, capacitive sensors in touchscreen devices. As ma'am told, capacitive sensors plays a huge role in modern electronic devices like smartphones, touch panels, tablets, etc. It works on the principle of capacitance. So it is mainly depends on the electric field between two conductive plates, where when the human fingers approaches the surface of the sensor, the electric field distribution changes. So the changes of this electric field distribution, the capacitance also changes. So that the system devices consider this as an input touch. So I like to continue this case study with Yamuna.
So whenever there is a change in the electric field, there is a change in the capacitance, and which is taken as an input to the particular devices. This is the concept behind the capacitive sensors.
So hello everyone, I am Yamuna from second ECC. Today I am going to talk about the background of the problem statement. So earlier stages we use mechanical buttons for controlling functions. These buttons should be replaced by touch screens nowadays. So it makes our work easier and more durable. But the engineers faced the problem. They needed a human touch screen without any physical switches. So the system had to detect the human touch screen accurately and works through glass screens. It should less the power and provides the fast response. To overcome these challenges, the engineers developed a capacitive sensing technologies, which is widely now be used like touch screens, smartphones, tablets, etc. And this topic should be detailedly conveyed by Vidya.
So the main drawback of the early days mobile phone is that the response is very poor and it is not user friendly. So to overcome that, they have developed this touchscreen concept and they have incorporated the capacitive sensors nowadays.
So hello everyone, I am Vidya from ECC. So I am going to talk about the working principle. So the capacitive sensors work based on the idea of the capacitance, which has the ability to store the electric charges. So the formula of the capacitance is C is equal to epsilon A divided by T, where C is capacitance, epsilon is material property, and A is area of the plates, and V is the distance between them. So in the touch screen, there are some electrodes which is kept like a grid under the screen. So these electrodes create small electric fields. So when we touch the screen with our finger, our body acts as a conductor connected to the ground. So when the electrode changes, the electric field also changes. So when the electric field changes, the capacitance also changes. So these these device controls the control detects where we touching the screen.
So the working principle is clearly explained by Vidya. And next.
So I'm Yoganila from secondary ECC. So I'm here to talk about the case study scenario of smartphone touchscreen project or experiment. So here the main system components are said to be transparent electrodes, glass protective layer, signal processing unit and capacitive sensing controller. So let us see about the process, how it works. So the system grid generates an electric field. So whenever a finger approaches the screen, the electric field gets altered. So because of the electric field gets altered, the capacitance also gets altered at that point. So the controller senses the multiple touch, exact location where the touching sense has been done. So the sensors also detects the multiple touching simultaneously with the help of the zoom, by zooming it or by touching the screen.
I'm Vikashni from secondary ECC. I'm here to continue with the advantages, limitations and the applications of the capacitive sensors. And first, the advantages of this is it is a high sensitivity and low power consumption and fast response, and its lifespan is very long. And the limitations of this capacitive sensor are it does not work with the normal glasses and sensitive to the environmental world. Thank you.
So we all had a discussion on this capacitive sensors, and we have discussed about the problem statement, and we have clearly illustrated the working principle as well, and finally we have ended with the application, drawback and also the advantages of the sensor. So this capacitive sensors is highly sensitive, and we have discussed about its application in touchscreen alone. Apart from that, it is used in proximity pad, and it is used in fluid level detection as well as it has been used in number of applications. So because of this advantageous property, it is being used in the touchscreen. So thank you all for your valuable points. Thank you.